All right, so graphing compound inequalities. When we see the word and, what we're looking for is a set of numbers that meet more than one set of criteria. So on this one, we're looking at x is greater than or equal to 5 and x is less than 8. So somebody raise your hand and give me a number that works. Alyssa? 7 works. So 7 would be a solution. It's bigger than 5 and less than 8. What would be another one?
6.
6. What would be another one?
6.
Okay. So let's talk about what this looks like on the graph, because there's actually an infinite number of numbers that work. So let's say that this is 8 and this is 5. What we do to figure out the graph of these is we graph each one separately and then we combine them. So here's what I'm going to do. I'm going to do a couple of pretend graphs down here that I'm going to combine up here. So this is down here is going to be my work. So if I want something greater than or equal to 5, I would fill in the point at 5, and it'd be all the numbers off till eternity that are bigger than 5 if I was just doing greater than or equal to 5. If I'm looking at numbers that are just less than 8, I would have a circle at 8 because it doesn't have the equal to bar, and I would have all the numbers off to infinity that are less than 8. So if I wanted to put the graphs together for all the numbers that are bigger than 5 on this graph and less than 8 on this graph, we would have this section here where they overlap. So how that's going to go actually on our final graph is you're going to have the filled in point here and the not filled in point here, and we're going to shade everything in between. So your numbers are right. We had 7 and 6, and you could do 5.5, 7.5. So all of those fit in here. But you can have an infinite number. You can break this into an infinite number of pieces between 5 and 8. So there's a lot of different fractions, decimals, things that you could get. But this is the entire set in graph form. All of them. Okay? Now the one thing I will point out, if you are looking for where they overlap for and, if there is an open point on one end, you have an open point here, because this point would not make both of them true. So anyway, let's do the next one. So it says graph the compound inequality x is less than 4 and x is greater than -2. So again, give me some points. Okay, so 3 works. What else?
-1.
-1 would work.
-1.2.
0. -1.2.
3.69.
3.5.
I wanted to say 6.9.
6.69. Okay, so let's go ahead and
She doesn't write it. She almost wrote it.
we're recording. So we're going to put both 4 and -2 on our number line. Now remember, -2 is on the left side. 4 is going to be over here somewhere. And so first we're going to graph them separately. This is where we're showing our work. And I do expect to see this when you're doing these on your own. So less than 4, I would have the open circle at 4. Goes to infinity this way. Greater than -2 looks like this. Goes off to infinity this way. I do draw these past where the other one ends just because that helps you find the overlap. So if I'm looking for the numbers that make this and this true, it's going to be on both of these arrows. So we're looking for this section between -2 and 4. So you'll have a segment between -2 and 4, and all of the infinite number of numbers between -2 and 4 get shaded in as the solutions. All right. So let's go down to the next one. Less than -1 and greater than 10. Can you come up with something for that?
-4.20.
Okay, but that's not less than -1.
Oh.
And it's not greater than 10.
Less than -1 would be -2.
Okay, so less than -1. So let's just look at what this looks like if we graph it. So here's -1, and over here is 10. So I'm looking for where x is less than -1 and x is greater than 10. Do you see the problem?
There is no answer.
There's no numbers that are over here and over here. It's impossible. And so for that, we're just going to say no solutions. Sometimes they will call this a null set. That's means it's empty. And there's a symbol for that. It looks like 0 with the slash through it. Like there is nothing there. So that stands for no solutions. Okay? So if I was looking for a number that's smaller than -1 and bigger than +10, it doesn't exist. So when you're looking at and, we want where it overlaps. Those didn't overlap. All right, so now let's look at number 4. So a number that's less than 3 and is less than 5. Can you give me something for that?
No.
Less than 3 and less than 5? You should have some. 2 is less than 3 and less than 5. What else is 1?
-1.
-1.
-400 million.
-400 million. I like it. So let's take a look at those two graphs separately. So I'm just going to put 3 and 5. So less than 3 would be going like this. Less than 5 would be going like this. So we're running the numbers that are less than 3 and less than 5. So we're looking for this overlap right here. So my answer where they overlap is not going to be a segment, it's going to be a ray from 3 to the left. Everything that's less than 3 and less than 5 all exists in the less than 3 arrow. So when we're looking at anything with and, so let me just zoom out. And if you have a little room in the middle, you could just make a little note. And we are looking for the overlap. When we're looking at the graphs, we're looking for where the numbers overlap, the ones that meet both criteria. So for most of them, and I should circle what our final answer is on all of these. I am looking for some work underneath, but then your final answer is what's going to go on the number line proper. Okay, so all of those were and. With and, there's something else that's special that you can do, and I would almost bet money you guys saw this on the PSAT. Not this, but what I'm about to do. It says write the compound inequality in the form A is less than X is less than B, then graph the compound inequality. So we have X is greater than or equal to -3 and X is less than 2. I'm going to graph this first over here so we have our bearings, kind of know what we're talking about. So if I'm greater than or equal to -3, that'd be from here over. And why did I fill in that point?
Because it's greater or
Because it's got the or equal to bar. Good. And then less than 2 would be open and would go this way. So where does that overlap?
In the middle.
In the middle. So what's my final answer going to look like?
In the middle.
Okay, a little more descriptive.
Draw a line and then draw it in the middle.
Okay, so lines in math have arrows on both ends. Is my final answer going to have arrows?
No.
Yes.
No.
Okay, where this overlaps is this part right here. That's going to be a segment. Okay, so we're going to have a point here and a not filled in point here and all of these numbers in here. There is a special way to write these. And it goes like this. -3 is less than or equal to X is less than 2. So I've already graphed it. It's up here. But this is a way that we can combine these. So essentially this part stayed the same. This part I had to flip around so that I could put X in the middle. But at some point, taking a PSAT, SAT, you're going to see this kind of notation for compound inequalities, where they're going to have a couple of symbols in there. Okay? So the next one just says we're going to write the compound inequality in the form A is less than or equal to X is less than or equal to B. So you're always going to put the X in the middle. Okay? This part right here, X is less than or equal to -5, I'm just going to copy down over here. But then this piece I'm going to have to flip because I put X on this side. So I'm going to flip this around and put -10 over here. And so that would be my compound inequality, where the X is bigger than or equal to -10, but is also less than or equal to -5. Does that make sense?
Not really. No. But we're going to go with it.
So we're going to put X in the middle. This part I just copied down. This part we're going to flip around. Because later on it's going to be easier to have one big statement than it is to have two
Keep the
sentences.
negative 10 and then switch the negative 5.
So that's a good question. She's asking if I could start with this. The answer is yes, but they won't in most textbooks. I'll show you what it would look like though. So x is greater than or equal to negative 10 like this. And then I could flip this one around and put the negative 5. And you could do this. The reason they don't like this is if you're looking at a number line, negative 10 is further to the left, so they like that further to the left on the notation, but technically this is not wrong. So yes, you could do that. The one thing that you are going to see is it's either going to be all less than signs or all greater than signs. All of those need to be pointing the same way. You can't have them going like this or like this. They have to be pointing either this way or this way. Okay.
That makes no sense, but alright.
It's because x is in between. And so if it's in between, you're going to have smaller number, bigger number, or it's in between bigger number, smaller number. If these weren't negatives, I think it would make more sense to you. Okay. It's okay. We're going to spend several days on this. Let's talk about ors for a minute because the ors are actually easier. So I have x is less than 3 or x is greater than or equal to 7. So if I am graphing this, let's put 3 and 7 on the graph. Less than 3, do I fill in the circle or not?
No. You do not.
Do not, and it goes to the left. And then do I fill the circle in on the second one? Yes.
It goes to the right.
And it goes to the right. I'm looking for a number that's either less than 3, which would be over here, or greater than 7, which is over here. It can be this one or this one. I don't need any. No, if it's or, it is possible. I can be over here or over here. I can't be here and here, but I can be here or here. What? So we're getting into some logic stuff that you would use to do computer programming.
Well, no logic.
I'm trying to teach you right now. All right, so really on the ors, for the most part, you're going to on most of them, you're just going to copy both of those onto your final graph. It's either less than 3 or it's bigger than 7. One or the other. So let's look at the next one. We have negative 8, and I'm going to put negative 2 here. If you want to put 0 there, you can, since those are negative numbers. So less than or equal to negative 8. What's that graph going to look like? Filled in or not?
Yes.
Yes. Does it go left or right?
Left.
To the left. And then x is greater than or equal to negative 2. Do I fill in that point?
Yes.
Yes. And it goes to the right. Okay, so I'm either over here or I'm over here. I don't have to be both. They're not asking us to do both. So that means both of these pieces individually are part of the solution. And I realize I'm doing the same thing twice on a couple of these, but that's because I know that there are special cases coming. All right, so let's go down to number 9. Graph the compound inequality. I want you to notice that both of these are going the same way. I'm going to make you guys edit this video. Like, that's where I'm at right now. We're recording. All right, so I'm at 3. Over here it's 7. If I have x is less than or equal to 7, I'm going to start by doing just some scratch work underneath the line. It goes like this. Less than or equal to 3 goes like this. It's important that you're making sure you show the arrows stopping at about the same place so you can see the overlap. If I am less than 7 or less than 3, could I be a number in here between 7 and 3? Yes. Can I be a number over here past the 3 on the left-hand side? Yes. Can I be bigger than 7?
No.
No. So my final graph is going to be from 7 to the left on this one. So if you are looking at an or situation, you really have to think about it logically. If I am less than or equal to 7 or less than or equal to 3, could I be 5? Well, yeah, because it's less than 7. It doesn't have to be less than 7 and less than 3. It has to be less than 7 or less than 3, which means all of this gets included. Okay. So one more on 10. wants us to graph less than 7 or greater than 3. So I'm using 3 and 7 again, but I've turned them around a little bit. So less than 7 would look like this, and greater than 3 would look like this. So if I'm a number that's either less than 7 or greater than 3, which part of the graph's going to go on my final answer?
That segment.
Well, that would be where it's greater than 3 and less than 7, but I'm saying or. So if it's or, couldn't I include these numbers over here, like 2 and 1?
Yes.
And couldn't I include numbers like 8 and 9, because it's either here or here? And I can include numbers that are in between. So if I'm including this piece, and this piece, and this piece, what's my final graph going to look like?
Just the whole graph.
The entire number line.
Yeah.
So I'm just going to darken in, literally, the entire number line.
Stop. I'm just going to box in the number line.
And then there's a couple of ways you can write this out with words. Sometimes they will say all real numbers. And there's a symbol for real numbers. It has like a double barred R. This symbol means all real numbers. And so that can be what we look for as well.
Andrew, you're an irrational number.
So on number 2,
Can I go to the bathroom? I'm having a girl problem.
Yeah.
so on number 2, we didn't do the same thing as number 10. Why is that?
Because on number 2, it has the word and.
Oh, okay.
And on number 10, it has the word or.
I like the ors more than I do the and.
So the ors could be whatever's on one and whatever's on the other. It's this or this. Everybody gets to come to the party.